Next technique of differentiation is product of functions. So whenever we have the product of two functions, how do we differentiate? So given that y is a function of u and product of u and v, where u and v are functions of x. Okay, then okay, the y dx will be equal to keep u differentiate v plus keep v differentiate u. Okay, since addition is commutative, we can as well write this as keep v differentiate u plus keep u differentiate v. Okay, so let's take a few examples on this. So we solved an example earlier where we have y to be equal to sine squared x. Okay, so remember that this can be written as sine x times sine x. So here we have product of two functions. So the same problem can be solved by using the method of product of two functions. Okay, so we'll take the first one as u and take the second one as what? As v. So we now apply the product rule. The product rule says that dy dx is equal to keep u, which is what? Sine x, differentiate v. If you differentiate sine x, what we have? We have cos x. Okay, plus keep v. V is also sine x, and differentiate u. U is what? Sine x. Differentiate that, you have what? Cos x. So clearly, if you add this together, this will give you sine x cos f plus sine x cos x, and that will give you 2 sine x cos x. Okay, which is the same thing as the result we obtained earlier. And to simplify this we simplify this further from our knowledge of math 101. So we have this as what? Sine 2x. Example, we have product of two functions. The first function is x squared, while the second one is tan x. Okay, so how do we solve this? You take the first one to be u and take the second one to be what? Tan x. Okay, so you know in that formula we need, that is, we have that u is equal to what? X squared, and then v is tan x. Okay, in that formula we need the derivative of u with respect to x and derivative of v with respect to x. So du dx will be equal to 2x, right? Good. Why dv dx is equal to what? Z squared x. Yes, from our standard derivative, z squared x. Okay, so we now apply that formula, the product rule. So the product rule says that dy dx is equal to u, what is u? X squared. Okay, multiply by dv dx. dv dx is what? Sec squared x plus, okay, plus v. V is what? Tan x, multiply by du dx. Du dx is 2x. Okay, so all we just need to do is to simplify. Okay, to simplify this, we're going to have x squared sec squared x plus 2x tan x, and that is the result. So for this, we have u to be equal to exponential 5x, and v is 3x plus 1. So du dx will be equal to, what's du dx? 5 exponential 5x, and dv dx will just be equal to 3. So we now follow that formula, that dy dx is equal to, look at it, it says u, what's our u here? Exponential 5x, multiply by dv dx. dv dx is 3. Okay, plus v is 3x plus 1, multiply by, what's that? du dx. du dx is 5 exponential 5x. Okay, so to multiply this, we're going to have 3 exponential 5x. Then here we have plus. Now we can multiply this, so that we have 15x exponential 5x plus 5 exponential 5x. Okay, I think we can collect like terms. If we collect like terms, we're going to have 8, look at it, 3 exponential 5x plus 5 exponential 5x. That will be 8 exponential 5x plus 15x exponential 5x. Okay, we can leave our answer this way, but among the options, we may find that exponential x has been factorized. Okay, if it is factorized, we're going to have 8 plus 15x in brackets multiplied by exponential 5x. Look at the solution to the exercise. Okay, so this can be solved in a number of ways. Are we together? It can be solved in a number of ways. If you look at it, you may see it as a function of function. You understand? You see it as a function of function. Okay, so looking at it as a function of function, so we have dy dx. So differentiate the inner function. To differentiate the inner function. So what do we have? Okay, we have a okay, 3 raised by x, yes, ln 3. Okay, that is the inner function. Okay, now we now multiply by, you know, you're having 2 times this one, 2 times of this. Okay, if you differentiate this now, like you're having 2x. Okay, so what would that give us? Okay, don't worry, don't forget that. What is what I'm saying? If you differentiate what you have here, looking at it as a function of function. Okay, you differentiated this one. We got this. Okay. So it's just like the x here was replaced by what? 3x. So just for you to differentiate two whatever that you have here. Don't forget that what would that give you? They still give you 2 now. I mean, right? Okay. Right. So that will be, so your result should be 2 multiplied by, okay. Okay. Another way you can see this is to look at it as lane 3, yeah, lane 3. Lane 3, of course. Lane 3. So if you look at this, you can see this as 2 times 3 raised by x means you have 3 raised by x plus 3 raised by x. I mean, 3 raised by x plus 3 raised by x is that now. Is that fully okay? So if you now differentiate this, you're going to have 3 raised by x ln 3 plus 3 raised by x ln 3. And that gives you 2 of it. So 2 times 3 raised by x ln 3. Okay. And you can look at it this way as 3 raised by x open bracket 2 ln 3. And you can look at it this way as 3 raised by x ln 9. So we have applied law of logarithm there, and that's why we're having 3 raised by x ln 9. How that's clear? This is something as ln 3 raised by 2. Okay. The second question on the exercise list, we have y equals to 2 raised by x cos root x. Okay, so again here we have our u to be equals to 2 raised by x and v to be equals to cos root x. Don't forget that this can also be written as cos x raised by 1 over 2. Beautiful, beautiful. So we differentiate it, the u dx will be equals to 2 raised by x ln 2, beautiful. And then we differentiate v with respect to x. That will give us, remember we need to differentiate this first. What would that give us? 1 over 2 x is by minus 1 over 2, right? Which will become 1 over, okay, which is 1 over root 2. Root x rather, okay? So that means 1 over 2 times 1 over root x, okay? Then differentiating cos, that will give us minus sign. So 1 times minus sine root x. So by the time we simplify this, we have minus sine root x over 2 root x. Okay. So the y dx will now be equals to u, which is 2 raised by x, multiplied by dv dx, which is minus sine root x over 2 root x, plus v, which is cos root x, multiplied by 2 raised by x into. Okay. So we can try to write the positive one first, so that we have 2 raised by x ln 2 cos root x minus 2 raised by x minus 1 sine root x over root x. So what have I done? I've tried to pick up these two that we have here. This one is 2 raised by x. By law of indices, that will become 2 raised by x minus 2x minus 1. The 2 here is having power of 1. Okay, so it's just that you're having 2 raised by x over 2. All together. So you subtract the powers. So that will be 2 raised by x minus 1. Then sine root x. Then the 2 will no longer be there again. And then we have root x. So that's the second one. So how do you get the answer? Is it this way? Or you're able to go further? Okay, that's fine. So now quotients of functions. Have that given that y is a function defined by u over v. Okay, where u and v are functions of x, then dy dx is equals to v du dx minus u dv dx all over v squared. So just like product rule, we follow this formula that we have written now. Just to identify your u, identify your v, then take the necessary derivative and then you substitute. So let's take your example. Show that d dx of tan x is equals to sec squared x. Show that d dx of tan x is equals to sec squared x. Okay, right. So we quickly record that let y equals tan x. Okay, and tan x I'm written as sine x over over cos x. Are we together? All right. So meaning that u, we have quotient of two functions, sine x and cos x, and we take u to be equal to sine x and v to be equal to cos x. So in our formula here, we need the derivative of u as well as derivative of v. So derivative of u here, du dx is equals to cos x, and derivative of v equals to x is equals to what? Minus sine x. And that's all. We just need to substitute back into the formula. So therefore, dy dx will be v is cos x multiplied by du dx is also cos x. Okay, minus u is sine x multiplied by dv dx minus sine x. Beautiful. Minus sine x divided by v squared. V is cos. Okay, so we have cos squared x. Beautiful. Cos squared x. Okay, so if you simplify this, we'll have cos squared x plus minus is plus sine squared x all over cos squared x. Okay, cos squared x. So if you look at this, cos squared x plus sine squared x equals 1. Okay, so we have 1 over cos squared x. But 1 can be written as 1 squared. So we have 1 squared over cos squared x. Now, since the power are the same, quickly recall that a raised to power n over b raised to power n is equal to a over b raised to power of what? N. Okay, so that means we can write this as 1 over cos x all squared. Good. But 1 over cos x is sec x. 1 over cos x is sec x. So we have sec x squared, and this is sec squared x. So that's why we have the derivative of tan x to be equal to what? Sec squared x. Example, we have y equals to x plus sine x over 1 plus cos x. So we let u equals x plus sine x, so that v will be equals to 1 plus cos x. Take the derivative of u with respect to x. This will be 1, plus cos x, and the derivative of v with respect to x, this will become 0, then this one will be minus sine x. So we now substitute into that formula, so that we have dy dx will be equal to v is 1 plus cos x multiplied by du dx, that's 1 plus cos x, okay, minus u is x plus sine x multiplied by dv dx, that is multiplied by minus sine x, right, divided by v squared, 1 plus cos x all squared. Okay, so here, if you simplify, like try to expand, you have 1 times 1, 1 times cos x plus cos x, right, then cos x times 1, that's another cos x, right, that will be plus 2, give me 1 plus 2 cos x, okay, plus cos squared x, right, cos x times cos x. Okay, now this is minus sine x here, and we have minus here, so minus times minus will become plus. Then we now have sine x times sine x, that will be sine squared x. Okay, then sine x times x, we have plus x sine x divided by 1 plus cos x squared. Okay, so clearly from here we have cos squared x plus sine squared x, that is 1. Okay, that is 1. So that we have 1 plus 2 cos x plus 1 plus x sine x over 1 plus cos x all squared. Okay, so this is equal to 2 plus 2 cos x plus x sine x over 1 plus cos x all squared. Okay, we can go further to do some nice thing there. Like, the nice thing is to look for the common factor here, which is 2. And we have 2 open bracket 1 plus cos x, then plus x sine x over 1 plus cos x squared, all squared. So we stop here for today. So thank you for your time.